All right, so moving on to lesson 5.3 from where we're talking about primary trig ratios. So the first thing that we're going to talk about is labeling the different sides. So we have the opposite side, adjacent side, and the hypotenuse. So the hypotenuse is always our one directly across from your right angle. When we talk about opposite and adjacent side, we're talking about in regards to the angle that we're looking for, because one of the things that we're going to be doing is using primary trig ratios, which is just sine, cos, and tan, the three fancy buttons that you end up seeing on your calculator all the time but don't use often. This is where we start using them. So we're talking specifically in regards to the angle that we're looking for. So if I am looking for angle A over here, the opposite is whichever one is directly across from it, and the adjacent is the one that attaches to it. So when we are looking at primary trig ratios, this is where we're starting to learn about what's called SOHCAHTOA, is what we're going to use to help us memorize those. So in this case, what we have to remember is that sine of the angle that we're looking for, so say this is, bear with me, the angle that we're looking for, it would be the sine of that angle is equal to the length of the opposite side over the length of the hypotenuse. So we get O over H. Cos of that angle is the adjacent side over the hypotenuse. A over H. And tan of the angle is the opposite over the adjacent. So we get O over A. So when we're doing this, the easy way to remember it is sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan is opposite over adjacent. And that's where we end up getting the saying SOHCAHTOA. That is just a quick, easy way to remember what you have to find for each angle. So when we put that into practice, if we are using this to find angles using trigonometric ratios, to find an angle, we must determine the proper labels for each of the sides that we have. So in this case, I know I am looking for X. I know that my hypotenuse is directly across from my right angle, so H is 13 meters. The angle adjacent to it, so the one that connects to that angle, is A, which in this case is 6 meters for the adjacent angle. And the one opposite of that angle is O for the opposite side. Oh, it should be a T. Oops. So now that we have this labeled, in this case, we know the adjacent side because we have 6 meters. And we have the hypotenuse, which is 13 meters. So we're going to use the trig ratio for cosine, because that is the one that matches the angles that we have, because cos is adjacent over hypotenuse. I have the adjacent, I have the hypotenuse. I don't have the opposite, that's what I'm looking for, so I can't use sine or tangent. So to do this, we are going to do cos of this angle is the adjacent over the hypotenuse. We know from the diagram that the adjacent is 6 meters and the hypotenuse is 13 meters. So that means, I'm just going to rewrite cos of x so we can see it over here. Cos of x is equal to 6 divided by 13 gives me 0.461538. We'll round it to 5. In order to solve this angle, you are going to end up using the second or shift button of your calculator. And then you are going to hit cos. You'll see that it comes up with a symbol that says cos minus 1, like that. If you were to do it for sine, you'd get sine minus 1, and or tan would be tan minus 1. This is going to be the opposite of cos. So here I have cos x, but I need to find x. Typically what we end up doing is we do the opposite of what we are looking for. So remember that cos minus 1 is equal to 1 over cos to the power of 1. This is cos to the power of 1, so those would end up canceling out. Just going to write that. So when we are doing this, now that I have cos of x is equal to 0.4615385, typically what I end up doing is just leaving it in my calculator, but I'm going to do cos over x goes to the -1. Not of x there. That was my bad. Get rid of those. And I get x is equal to about 62.5. So I know now that if the adjacent side is 6 meters and the hypotenuse is 13 meters, that means that angle x is roughly 62.5 degrees. Awesome. So now if I'm looking here, I'm going to find each missing angle in the triangle below, start by labeling the sides of the triangle and stating known information. So all we are doing is essentially learning different trigonometric functions that allow us to find any missing information that we're looking for. All right, so when I take a look at this diagram here, my first step is always going to be to label my sides, label anything that I know. We know I have my right angle here because the square. Opposite of that is hypotenuse. This now depends on how I'm going to look at it to figure out all the information that I need to know. But I know in this case that if I find either A or B, I can find the other one because this is equal to 90. And the internal sum is 180 minus 90 minus, in this case, we'll say that we're going to look for A. So this is what B would be equal to. You could do the reverse by solving for B. It does not matter. It just matters that you follow through appropriately. This is just how we will approach it for the lesson. So if I take a look, my one opposite of that is my 3 centimeters, and the one adjacent to that is unknown. So that one's going to get a capital A. I don't know A, so if I take a look again at, I can't use tan, I can't use cosine because I don't know my adjacent angle. What I can use is sine. So I know that the sine of angle A is equal to opposite over hypotenuse. So in this case, it's equal to 3 over 5 centimeters. This is equal to 0.6. So sine of A is equal to 0.6. And then do over sine and times my inverse of sine. So I get A is equal to which in this case is going to give me roughly 36.87 degrees. So I know that A is 36.87 degrees. Now I'm going to substitute this in here, and I will get B is equal to 180 minus 90 minus 36.87. Gives me 53.13 degrees. So that's what B is equal to. That's what A is equal to. And then I'm done. If I go on to B to check for that one, first thing again is that we're going to determine all of our angles. So I know opposite of my right angle is always hypotenuse. In this case, I can solve for either E or F. So say in this case, I'm going to solve for, E. The opposite of E is unknown. The adjacent to E is 1 meter. If I take a look again at, SOHCAHTOA, I know I don't have my opposite, so I cannot do sine, I cannot do tangent, I'm going to do cosine. So I have the cos of, E is equal to adjacent over hypotenuse, which is equal to 1 meter over 2 meters, so this is equal to 0.5. If I do the cos of that, which is the same as times the cos of the inverse, I will get E is equal to cos inverse 1, 0.5. I type that in, I get 60 degrees. I know E is 60 degrees. I know that F is equal to 180 minus 90 minus 60, which is 180 minus 90 minus 60. I get 30 degrees. So F is equal to 30 degrees and E is equal to 60 degrees. We do that one more time. We will take a look here, and I'm going to label all of my angles. H is unknown. If, say, I'm solving for D, my opposite is 8 kilometers, and my adjacent is 7 kilometers. I know I don't know H, so I can't do sine, I can't do cosine, I can use tan for the tangent. Tan of D is equal to opposite over adjacent, which is equal to 8 kilometers over 7 kilometers. This is equal to 1.1428. Oh, that's supposed to be an 857. Do the inverse of tan, which means D is equal to 48.8 degrees. C is 180 minus 90 minus 48.8, which is equal to 41.2 degrees. Awesome. So finding sides then using trigonometric ratios. To find the length of a missing side using trigonometric ratios, we can set it up in the same way we did when solving for angles. All we are going to do is rearrange things a little bit depending on what we are looking for and what side we're looking for. So when I take a look at this one, again, first thing I'm always going to do is identify my angles or my sides. I have the opposite. I know 50 degrees, but I don't know this one, so I have to use my 50 degrees as my spot. The opposite of that is unknown. Here we have the adjacent of that is x, which is the value that we're looking for. So in this case, I know between so, ka, doa, I'm looking for angle x or side x, which is A, so it's my adjacent. So I know I have to use either cosine or tangent. I cannot use tangent because I do not know my opposite. So that means I'm going to use cosine. So it would be the cos of 50 is equal to the adjacent over the hypotenuse, which is x over 12. So I end up getting cosine of 50 is equal to x over 12. I know to get rid of this 12, this is divided by, so I'm going to multiply by 12 so that those cancel out. Whatever I do to one side, I must do to the other. So x is going to be equal to 12 times the cos of 50. So if I type cos of 50 into my calculator and then times that by 12, I will get 7.71. In this case, it's meters because that's what my sides are measured in to begin with anyways. All right, so after writing out the proper ratio, essentially what we're doing is just either cross multiplying or looking at how we originally did it. And then if we had division, multiply by the top. It just depends on what angle you're looking for. If you're looking for the hypotenuse when it's on the bottom, you were always going to have to use some cross multiplication to figure it out. So when we take a look at this, if I move on to the next example, I'm going to use the trig ratios above to find the missing side in each of the angles below. First thing I'm going to do is label my sides. This is my hypotenuse. The angle I have is 60. So x is what I'm looking for, is my opposite. In this case, I have opposite and hypotenuse. So I know, second I write them out, I need to use sine of 60 is equal to x over 10 meters. I'm going to multiply by 10 to get rid of that. So I end up with x is equal to 10 times sine of 60. If I type sine of 60 into my calculator and times that by 10, I get 8.67 meters. If I take a look at this example down here, again, always label first. Opposite of my right angle is my hypotenuse. I have the angle of 45, and the one that I'm looking at is the one that is adjacent to it. I know I have opposite, or the adjacent and the hypotenuse, which is the cosine law. So if I use the cos of 45 is equal to adjacent over hypotenuse. Now I'm looking for hypotenuse. Because this is equal to, I meant to write the actual values in there, 3 kilometers over z. So remember, this is over 1. I'm going to cross multiply, and I will get cos 45 times z is equal to 3 kilometers. So that means if I get rid of this, I need to divide by cos 45 over cos 45. So z is equal to 3 divided by cos of 45, the cos of 45. So that gives me 4.24. kilometers. Awesome. And that is everything for this lesson.